Okay, hello. So for today I will show you how to use oscilloscope. Okay, so make sure you watch the probe instruction first, how to use how to choose probe. Okay, so after you choose the probe, okay, now you can move on to the oscilloscope. So of course this is one of the oscilloscope, the Tektronix TDS2024C, which is a lot of it in the lab. It's quite old, but you still can use this, and you can put pen drive here. Okay, so for your application I think no problem because it can support up to 200 megahertz. But for research application I don't suggest to use this because the speed is not too fast and you cannot record a lot of data. I think if it's around 2000 points only. For research usually you need around 10,000 points to save. Okay, so how to turn on? Usually at the top, just turn on. Okay, it's take usually around 1 minute. Okay, so for oscilloscope no need to worry, even though this is a different version. If you use different version, the term used are usually the same, all the same, mostly the same. Okay, so first thing you have to do is, when it comes to oscilloscope, you have to do calibration. So for the differential probe, you have to, for example, connect. If you choose to connect to probe 1, okay, just use this one. Okay, make sure you check the video of the probe first because of the compatibility issue. Okay, so this is the probe. Red always positive, black always negative. Okay, so how to calibrate? First you have to turn on the differential probe and choose the correct range. Okay, for this case I only use a very low voltage, so 140 should be okay. Then this one, you can see usually oscilloscope near the screen there is some sort of pin. Let me show you. Okay, this one. Okay, so you just connect this to calibrate it. Okay, connect and connect the ground also. Okay, so you can see there is a signal here. Press auto set. Usually you have to find something called auto set. Basically it's automatically set everything for you, so press it. Okay, so you can see here you can have a signal. Usually you can check there is a writing near the deer. Make sure it is the same here. For this oscilloscope is 5 volt 1 kilohertz. So wait, okay, so where is back? Okay, so you can see here it is 1 kilohertz. So 1 kilohertz, the signal is 2 volt per division for channel 1. This is channel 1. The yellow is channel 1. So you can see 2 volt. So 2, 4 and 5, half of the box, 5 volt. Or you can see here 5 volt peak to peak. Okay, so means that this probe is okay. If not, you have to adjust something. Okay, so if not correct, usually the problem is either this is broken. If the signal is not square wave, means that the differential probe is broken, so you have to find another one. Or if the voltage is not 5 volt, okay, you can see here this is 5 volt. Okay, you have to click here because you put a channel 1. Okay, click 1. Okay, and you have to choose the correct one. So this one is, click here. Okay, it is voltage correct, but the attenuation you have to set it. So for this case the attenuation is 1/20, so you have to multiply by 20. So usually that is the problem, but usually it can solve itself. Okay, so that is how you calibrate the probe. Okay, and then next is you have to calibrate the current probe. So for current probe, usually it's much more simple. Okay, so let me find, where is it? Okay, this one. Then set it up. Okay, I think for this case, okay, so because this is channel 2, of course the probe you have to turn on first. Current probe usually required power, and you have to choose the correct range. Okay, this one is higher current, but if your current is low, choose 1 millivolt per ampere, or the other way around, if not mistaken, the other way around. Okay, so 100 millivolt per ampere. So this is low current, 10 millivolt per ampere is high current. Okay, so this one, so you have to turn on, just press the blue button. Okay, so now it's turned on, and usually you have to set manually for current probe. So same thing, press this. Okay, press until turn on and then set it. So this one is AC, bandwidth limit, usually no need to worry. If you have a lot of noise, maybe you can turn it on. Okay, but no need, usually no need. And for this one, you have to change it. Okay, this one. Okay, cost fine, no need to worry. Press this, and because this is current probe, you change it to current. So originally voltage, usually you have to change to current, and you have to follow this. Okay, so because I set to 100 millivolt ampere, make sure you set it to the same one. Some oscilloscope use different format. Okay, but for this case, okay, you have to use the top format. So this one should be this one. This one is 100 multiplied by 100, means that this is the lower current. Okay, so 100 multiplied by 100, or other way around, I'm not sure. Okay, but make sure you set it correctly. Okay, this one is the correct one. Okay, that is how you calibrate the probe. So basically, each time you want to use this, you have to calibrate. Okay, if not, you will get wrong answer. Each time you want to, every time you turn on, you have to calibrate again. So that is the first part, which is calibration. Now after you complete the calibration, you have to know how to use this. The common thing that you need to know is the measure. So you try to find anything that called measure. So click measure. Okay, you can see this is a reading. Usually you can just click here. Okay, you can change, okay, either channel 1 or channel 2. Okay, then you can check the frequency, or if you want to change, just click this period, mean. Okay, a lot of it available. Okay, for time. Okay, for this case, I just choose frequency. Maybe for the bottom one, this one, I change to channel 2, and I want to read mean value. Okay, so back, and then this one, for channel 2, I want to read the peak to peak, for example. Okay, so that is how you get the measurement. Okay, it will show here. Okay, that and then another thing that you need to learn is how to use cursor. So this is cursor. Okay, so if I press cursor, okay, you can choose what type. Okay, either amplitude or time. So usually time, and then you have to choose the you have to choose the source, either channel 1 or channel 2, and so on. And then you usually have this one. Okay, usually if you have cursor here, this is the general knob to adjust it. Okay, okay, so you can see this is the cursor, the first cursor. So you know you have two cursor here. the first and the second one. Okay, some you have to press this, but for this case I think you have to press this. Okay, cursor number 2. Okay, you can move. Okay, for example, if you want to measure from here to here, okay, maybe I should give an example here. Oh, okay, I don't have any example, but it's okay. So you can measure, for example, the signal is something like this, and you want to measure from here to here. Okay, from here to here, for example, and you can get the time difference. See, time difference is 1.26 millisecond. Okay, that is for this one time. But if you want to change to amplitude, okay, also can you adjust it from here and then change to cursor 1, cursor 2, and then you can get the amplitude from here to here. Okay, that is quite useful function. Okay, and then another thing is map. You can see here, this is map. So basically map, you will add if you want to do operation, for example, channel 1 minus channel 2, or channel 1 commonly channel 1 multiplied by channel 2. Okay, what it means that you want to find power. Okay, voltage multiplied by current, you get power. So you press map and you do the operation. What channel is it? Okay, channel 1 and channel 2, and you set the amplitude. Okay, so the scale, you have to change the scale. Okay, and this one, and then position also you can adjust. Oh, before I forget, so I turn off map first. Okay, so for channel 1, for example, you press channel 1. If you want, this one is 2 volt per division. This one means that each division is 2 volt. So if your signal is quite large, you turn this. Okay, you have 20 volt per division, so each division is 20 volt. But if your signal is too small, this one, okay, you zoom. So this one is 400 millivolt per division, but you can see there is a waving. Okay, this one is noise, so be careful. I suggest your channel should be your voltage level should be above 1 volt. If less than that, means that it can be noise. So you can see here, this is noise. Okay, 1 volt should be okay. Okay, and above. So for power electronic research, usually above that. Okay, make sure you take care of this. Anytime you want to measure voltage, it should be above 1 volt. Okay, and if you, for example, this one is 1 volt, and then you adjust. If you want to adjust the location, you can see here, this one is set to 0 at the middle. But if you don't want to put there, maybe you want to move at the upper side, you adjust the knob. This one, this is the offset. Okay, so adjust the offset, the voltage is now at the bottom. And if you want to adjust the current, see, at the bottom. Sometimes people like to do this. So the upper side is the voltage, the lower side is the current. So you just adjust for this. This is the position, this is the scale. Same as the current. For current, also try to be more than 200 milliampere. More than that, you can see there is a noise. Okay, 200 milliampere should be okay. Okay, so that is how you set. And also this one I already show you how to set. And then for the time, so for the time you can adjust it. This one horizontal, this one is vertical, this one is horizontal. To adjust the time, same here. This one is the position. I suggest just put at the middle here. And but for this one is important. Okay, you can see here, this is the common mistake happen. So you can see this is 500 microsecond per division. So 500 microsecond. Okay, if you zoom too much, it will be measuring noise only. Okay, so I suggest for this case you have to calculate lah. I suggest for example, if your frequency is 10 kilohertz. Okay, so let me take a calculator. For example, 10 kilohertz is not usually 50 kilohertz. So 50 kilohertz, they want to find the period is 1 divided by 50000. Okay, 50 kilohertz. And then you get the 20 microsecond. So I suggest for this case, one division is cover, two division will cover one 20 microsecond. How I can say this? Okay, so because our period is 20 microsecond, I suggest 25 should be okay. Try to choose a near value to this one. Okay, so you can adjust it accordingly. Okay, make sure it's close. Okay, if you choose too small, it's basically just a noise. Okay, this one is too small. Okay, it will be noise. But you can set it to high if you want to measure the transient response. Okay, if you want to measure transient response, maybe you have to choose the higher value. Okay, for example, if you have signal something like this, okay, the settling time is around 10 milliseconds. I suggest your scale also maybe 1 of 10 milliseconds, maybe 1 millisecond. Okay, make sure you choose the correct scale. That is quite important. If not, you just get the noise. So this is how you know the value. Okay, another things that you need to know about the oscilloscope is trigger. This is trigger. Okay, so for this case, how so maybe I have to connect the circuit first. Okay, differential current probe, I'm not sure why it doesn't work, so I just leave it there. So the differential probe should be okay. So I turn this on. Okay, so this one, this is the load. So you can see here. Okay, so you have to adjust the scale. Cannot be too small. This is too small. Okay, this one should be okay. Okay, maybe cursor I turn it off. Off. Okay. Okay, measure. Okay. Okay, so you can see this is the result. So if I turn it off, it will be 0. If I turn it on, will be this one. So the trigger is basically this one. You want to look at the transient. So if you adjust here, this is the trigger, and you press the trigger menu, you choose the channel. Okay, and you set to H. Okay, so you can see here it should be locked. Okay, for this, okay, the mode I forget to set. Okay, so if you turn it on, so you can see during the transient response. Okay, so this one is the trigger menu. For example, this one I want to see how it turn off. I turn on to turn off. Okay, so I set the trigger level. So this is when it is trigger. So I turn this off, and okay, doesn't work. Oh, because this is rising, so I have to change to falling. Okay, see, you can see the voltage drop. Okay, so that is the function of trigger. This is very useful when you do the FYP or research, because you want to see the transient or dynamic response. Okay, so that is how you use trigger menu. So if you want to change it, so for example, change this to falling back, rising, and you want to have only measure. Okay, so if you run this, it can record everything. Okay, so that is how you use trigger. And of course, you want to put pen drive here. Okay, if you want to save something, okay, you put the pen drive. For this version, you have to Google it. This one is 64 bit megabyte, 64 gigabyte maximum. Okay, you have to find pen drive that is 64 megabyte or lower. Okay, so you go to the utility, I think. Okay, so data logger. Okay, so let me check first. Okay, so safe recall, usually there is called this one, different oscilloscopes sometimes have different name. Sometimes they call it print, sometimes they call it save. So the button is this one and this one. So first you have to set this, so save recall. Okay, so either you can save image, means that it screenshot this one, or save with. Okay, I suggest just save all, save to file. Okay, so that one, sometimes they have ink saver. Ink saver basically, this one is black, right? But when it's saved to picture, it turns to white, so much more clear. Okay, so I suggest just save all. Save all means that you have take screenshot and as well you get the data. Okay, the Excel file. Okay, of each point. For this version, it takes 2000 points if not mistaken. So you can plot back in the MATLAB or something else. Okay, but also I suggest you save the picture. Usually they want the proof of the hardware by using the screenshot. Okay, and of course don't forget, if you want to turn off the trigger, don't forget change this to auto. Okay, then it will become normal again. See, so I think that's it. Oh yeah, after you set it, if you want to save, just press save. Okay, for this case I have to insert the USB. Okay, wait, I find USB. Okay, so I put a USB. So if I press save, okay, it will save the screenshot as well as the data, and it takes quite a long time. And it will give a name, and make sure you write the name. Okay, for this data, for this name of the data, what is it about? Usually you have to do like that. If not, you will lose. Okay, so it's quite long. Okay, now it's saved to file called ALL0000. Okay, and if you want to measure also, click measure. You can see there is a measurement data. Okay, you click save. Okay, it will save this one also. Okay, even the cursor, if you want to set the cursor as a proof and then you save it, it will save the cursor also. Anything that is come out will be saved. Okay, so that's it. I think for FYP level or for research level, that is all the function that you need to know for the FYP. External trigger, I think no need. Data, there is also data logger, no need to worry on that. Okay, yeah, I forgot about stop and run. For example, if I run this, okay, so I want to, sometime maybe the signal is not stable, moving up and down, you want to stop it first, you can just press stop and run. So basically the signal will stop. If not, it will keep changing. Okay, keep changing. So you want a good result, just press stop. Okay, it will not move. So I think that's it for the oscilloscope. Okay, remember, calibrate first and then adjust this one, and then you can set the measure, set the cursor. Either way, this is a function. Okay, and then if you need the trigger during the transient response, this is the place, and then you have to know how to save. Okay, that's it.